First, I want to explain what differentiation is, and I will leave this definition here. When we differentiate a function, f of x, with respect to x, we create a new function that tells us the rate of change of the function f of x with respect to x. If we make the statement y is equal to fx, we can just replace all the fx's in this sentence with y's. And it means exactly the same thing. For most of these lessons, I would just use the letter y rather than writing fx when we talk about differentiation. But to introduce differentiation, I must do it in terms of functions. If you are not clear on functions, I recommend watching the functions video series in the GCSE maths section. What is the rate of change? The sentence rate of change of y with respect to x is the same as how much does y change for every bit that x changes. For example, the rate of change between my wealth in pounds and the number of £2 coins I own is 2, because for every extra coin I get, my wealth increases by 2. We know the value of a function f of x tends to change as x changes. We want to know how fast it is changing. A graph offers us a new way of looking at the rate of change. What we are now interested in is the rate of change of the y-coordinate with respect to the x-coordinate for points on this curve. In other words, the rate of change is just the gradient of the curve. We can see that this function here has a gradient that changes a lot. You should know that to measure the gradient at a given point on a curve, we measure the gradient of a tangent to the curve at that point. So here it is negative, here it is 0, and here it is positive. We want a function that will tell us the gradient of this graph at every x value. And differentiation is what brings us from the original function to this gradient function that we want, which we call dy by dx. Here I have drawn the function y is equal to x squared, and I'm going to tell you that the differentiated function dy by dx is equal to 2x in this case. What this means is that if we want to know the gradient of this x squared curve here at any point, we just input the x-coordinate of that point into this function 2x, and it will give us the gradient. For example, the gradient at x equals 4 is 2 times 4, which is 8. The gradient at x equals 0 is 2 times 0, which is 0.